In the strategic landscape of Eastern Europe, a profound transformation in military operations has unfolded. This is not a narrative dominated by conventional force projection, but by the pervasive influence of unmanned aerial systems. This documentary analysis examines how drones have fundamentally altered the tactical and strategic calculus of modern conflict, using the Russia-Ukraine war as a critical case study. When the full-scale Russian invasion of Ukraine commenced in February 2022, initial assessments focused on traditional military capabilities, armor, artillery, and air power. However, beneath the surface of conventional maneuvers, a technological paradigm shift was already in motion, driven by the rapid integration of unmanned systems. This shift was characterized by the urgent adaptation of readily available commercial technology for military purposes. Both Ukrainian and Russian forces, facing immediate operational requirements, began repurposing civilian drones. Initially inexpensive quadcopters designed for photography and recreation, to fill critical gaps in their intelligence, surveillance, and reconnaissance (ISR) capabilities. The initial phase saw widespread use of platforms like the DJI Mavic series. These commercial drones, while limited in range and payload, offered an unprecedented level of localized situational awareness at low cost and risk. They provided real-time video feeds enabling frontline units to scout enemy positions, identify artillery targets, and assess battle damage. This rapid adoption was a direct response to the operational environment. Ukrainian forces, facing a larger adversary, leveraged these tools to gain asymmetric advantages in reconnaissance and targeting. Russian forces also employed similar tactics, recognizing the value of persistent overhead surveillance in complex terrain. The role of drones quickly evolved beyond passive observation. The conflict became a proving ground for the integration of offensive drone capabilities, moving from simple reconnaissance to direct strike missions. This marked a significant escalation in the operational utility of unmanned systems. A key development was the widespread deployment of first-person view, FPV kamikaze drones. These small, agile systems, often built from commercial components and guided by operators using VR goggles, provided a low-cost, high-precision strike capability. They proved effective against a range of targets, including armored vehicles, personnel, and fortifications. Certain drone platforms emerged as symbols of this new era of warfare. The Turkish-made Bayraktar TB2, a medium-altitude, long-endurance, male UCAV, played a significant strategic role in the early months of the conflict. Equipped with electro-optical infrared sensors and capable of carrying laser-guided munitions, the TB2 provided Ukraine with a potent strike and reconnaissance asset. The TB2's ability to conduct targeted strikes against high-value targets, such as command posts and logistics convoys, had both material and psychological effects. While its vulnerability to sophisticated air defenses became apparent over time, its initial impact underscored the potential of armed drones to influence operational outcomes. The proliferation of drones necessitated the rapid development and deployment of countermeasures. Electronic warfare, EW, became a critical domain, with both sides employing jamming systems to disrupt drone control signals and GPS navigation. Anti-drone rifles, kinetic interceptors, and cyber attacks were also utilized in an escalating technological arms race. This dynamic created a complex environment where drone effectiveness was constantly challenged by EW capabilities. Operators and manufacturers were forced into a continuous cycle of adaptation, developing anti-jamming techniques, redundant control systems, and alternative navigation methods to maintain operational viability. The conflict spurred the development of a unique, decentralized drone manufacturing ecosystem, particularly in Ukraine. Driven by necessity, innovation flourished through a combination of military requirements, civilian tech expertise, crowdfunding initiatives, and rapid prototyping. This grassroots approach allowed for quick iteration and deployment of new drone designs tailored to specific battlefield needs. This model contrasted with traditional defense procurement, enabling the rapid scaling of drone production. Russia also expanded its drone capabilities, leveraging domestic designs like the Lancet loitering munition and incorporating foreign platforms such as the Iranian-made Shahed 136. primarily used for long-range strategic strikes against infrastructure. The pervasive use of drones has fundamentally altered battlefield tactics. In urban environments and static trench lines, drones provide persistent overhead surveillance, making concealment difficult and enabling precise targeting of individual soldiers or small groups. They have become essential tools for adjusting artillery fire, conducting damage assessments, and identifying enemy movements in real time. Beyond lethal applications, drones have demonstrated significant utility in non-combat roles. They are used for medical resupply, delivering critical items like blood and tourniquets to the front lines. Drones equipped with thermal cameras assist in search and rescue operations and mine detection, highlighting their versatility and life-saving potential. The conflict in Ukraine serves as a critical case study for military planners and policymakers worldwide. It demonstrates the transformative impact of relatively low-cost, widely available technology on the conduct of warfare. Nations are observing, analyzing, and adapting their defense doctrines and procurement strategies in response to the lessons learned. The future trajectory of drone warfare points towards increased autonomy, AI integration, and the potential for large-scale swarm operations. The conflict has accelerated the development of counter-drone technologies and highlighted the need for layered defenses. The cost-exchange ratio, where inexpensive drones can destroy significantly more expensive traditional military assets, presents a strategic challenge for conventional forces. The war in Ukraine has unequivocally demonstrated that unmanned aerial systems are no longer supplementary tools, but integral components of modern military power. They have reshaped reconnaissance, strike, logistics, and electronic warfare. The rapid innovation cycle driven by battlefield demands and technological accessibility suggests that the evolution of drone warfare is far from complete. This conflict serves as a stark reminder that technological disruption can rapidly alter the balance of power and the nature of combat. Understanding the strategic implications, technical challenges, and tactical applications of drone warfare is essential for military analysts, tech enthusiasts, policymakers, and war historians seeking to comprehend the future of conflict. To delve deeper into the technical specifics, strategic implications, and policy challenges presented by the proliferation of military drones, explore detailed analyses from defense research institutions, engage with experts in unmanned systems technology, and study the evolving doctrines being shaped by the lessons of this conflict. The future of warfare is being written in the skies above Ukraine, one drone flight at a time,